Reduce is a tricky method in JavaScript, and that prevents a lot of programmers from realizing just how powerful and flexible of a tool it really is. But once you get the hang of it, you'll see that you can use it in a lot more places than you might have thought. So what exactly is reduce? If we look over here at the MDN docs, which is always a good thing to do if you're feeling a little bit lost, we see it says, the reducer method executes a reducer function that you provide on each member of the array, resulting in a single output value. If we look down at the syntax, we see that we call reduce directly on an array. We pass in a callback, optionally something called initial value. This callback also takes a couple of arguments, something called accumulator, something called current value, and then optionally current index and array. So what does all of this actually mean in practice? Well, we can dive into what this means by looking at an example. So here I have an array called wallet, and inside of that wallet are a couple of elements that represent bills that we might find in a wallet. And what we want to do is use reduce to tell us how much money is in this wallet. We want reduce to add up all of these values and tell us how many dollars we have. So before we jump into writing any code, I think it might be productive to think about how we might tackle this just as humans without any computers helping us out. So if I wanted to see how much money I have in my wallet, what I would do is open it up, see what the first bill I find is. The first bill is a 1. So I know I have at least $1. I move on to the next bill, it's a 20. So I add 20 and 1, and now I have at least $21. Keeping that 21 in mind, I move on to the next bill. This is a 5. So I add 21 and 5 and see that I have $26. Keeping that 26 in mind, I move on to the next bill, which is a 10. So I add 26 and 10, and now I know that I have $36. And I notice that there are no bills remaining in my wallet, so I know that the total amount that exists in this wallet is $36. So if we look back at the docs, we see that it says something about returning a single output value. So it makes sense that the 36 here would be that single output value. So then what is this reducer function that they're talking about here? Well, below the wallet, I've defined something called sum2numbers. It's a function that does basically exactly what it says it does. You pass in two numbers and it returns their sum. But our wallet has 4 bills in it. So how are we supposed to use this sum2numbers function to add up 4 different bills? Well, it turns out reduce can do that for us. So what I'm going to do is create a constant called sum and set it equal to the value of calling reduce on wallet and passing in sum2numbers as a callback. So let's see what sum is. Well, yeah, it's 36, just like we expected. So how is this function that only deals with 2 numbers at once adding up all these 4 here? I think it might be useful to ignore sum2numbers for now and just write an anonymous callback directly into the arguments of reduce, just so it's a little easier to see what's going on. So it's also going to take in 2 parameters, but rather than calling them num1 and num2, I'm going to call them accumulator and current value, like in the documentation. And what I'm going to do is return accumulator plus current value. And once again, our sum equals 36. So what exactly is the accumulator and what exactly is the current value? Well, let's think back to how we were adding up the values in this wallet earlier. You should notice that we always had 2 different numbers in mind. One of the numbers we had in mind was this sum. And every time we come across a new bill, that sum is growing, that sum is accumulating. It's just growing in value. And the second number we had is the current bill. This is basically what reduce is doing under the hood. And to show that to you, I'm going to add in a couple of strategic console log statements, and we'll see what those give us. Okay, so we see, first of all, it looks like this is running a couple of times. Much like I said in the documentation, we execute this reducer function for everything in the array. So the accumulator starts off as 1, and the current value starts off as 20. So it looks like the accumulator, the first time this function is executed, gets the value of the first thing in our array, and the current gets the value of the second thing in our array. So we see that we are returning the result of adding the accumulator and the current value. So the accumulator plus the current value is 21. And we see the next time this reducer function is called, the accumulator is now equal to 21. So what we can gather from this is that whatever we return from within a reducer function, that's what is assigned to the value of the accumulator for the next time it's called. So we've gone from this 20, we move on to the next, which is 5. So now we see our current value is 5. So we add our current value in our accumulator, that's 26, we return that, and now for this next execution of our reducer function, the accumulator has been assigned the value of 26. And our current is now the next element in the array, which is a 10. So we add 26 and 10 and return that. So now there's nothing left in this array. So instead of going on to some undefined next element, reduce just says, okay, there's nothing left here, so I'm just going to return that out of reduce and assign that to sum. So we see that sum gets the value of 36. So that's how this is working. It's basically working the same way that our minds work to add up all the numbers or all of the bills that are in our wallet. But that's not the only thing that reduce can do, though. We saw that this can also optionally take something called an initial value. So let's just say you're in a parking lot, you just got out of your car, and the first thing you see on the ground is a fresh $50 bill. So you're having a really good day. I'm going to represent that with another constant called lucky bill. So that's a 50. So in your excitement, you've already forgotten how much money you have. But now that you've come into this extra money, you want to know how much you have on you. So you want to count up all your money again. So this time, instead of opening the wallet and seeing what the first bill is and starting there, you start with this new bill that you just found on the ground. So you know you have $50. Knowing that, now you open up your wallet, you see that the first bill is a 1, you add 1, now you know you have $51. Keeping that 51 in mind, you move on to your next bill, and so on. So it's going to be the same process, except this time you're just starting somewhere new. So we can represent this by adding in a second argument to our reduce function. Right after the callback, we can just provide an initial value. In this case, it would be lucky bill. And now we see that the sum becomes 86. So what's going on with our accumulator and current values here? I'm just going to zoom out a bit so we can see all of this. So we see that the first time this reducer function gets called, our accumulator is assigned the value of 50. So it looks like when we provide an initial value, that is what gets assigned to the accumulator. And now the current value is 1, which is the first thing in our array. So that can be a little bit tricky to get used to, but the point is reducer has to start accumulating value somewhere. If we don't explicitly give it some external value to start accumulating with, it'll just pick out the first thing in our array and the current value will start as the next thing, because otherwise it would just count it twice and that would give us an incorrect sum. But if you do pass in something explicitly, if you do pass in something like this 50 here, then that will be what the accumulator is, and then everything in the array will be passed through as a current value. But everything else follows the same pattern. The accumulator starts as 50, the current value starts as 1, we add those two things together, return it, and the next time this function is called, that is now what the accumulator will be assigned. It'll find the next bill, which is a 20, adds those two things together, it's 71, so we return 71, and the accumulator is assigned 71 for the next time this is run. The next bill is a 5, we add 71 and 5, return 76. The accumulator on the next run, the next time this is called, is 76. And we reach the next bill, which is a 10. So we add 76 and 10, and we get 86. And since there is nothing else in this array, reduce returns 86 and assigns that to sum. So your sum is 86. You have $86. Go you, honestly, go buy some donuts. You can afford it now. So this is how reduce is working. It's pretty much following the same sort of pattern that we were using earlier when we were adding up things by ourselves. So that was fun, but let's use reduce to do something a little trickier. So the documentation said that reduce returns a single output value. So let's think about what kind of data types we can use in JavaScript. There are, primitive data types like strings, booleans, and numbers like we used in the last example, but JavaScript also has more complex data types like objects and arrays. And no matter how complex these things get, no matter how many thousands of elements you have in an array, no matter if you have 100 different properties on an object and each of those properties are nested objects with 100 properties of their own, these things are all still just one value. You can save the most complicated object you can possibly write to just one variable. So all of these can actually count as a single output value. So with reduce, if you want to do something a little trickier, you just have to be creative about the sort of initial value you're giving it. So let's look at this example here. We have this array with 30 different numbers in it, and we want to use reduce to tell us how many of these numbers are odd and how many of them are even. So a good way to do that, to wrap all that up in a single value is, for example, you could have an object that has an even property and an odd property, and each of those properties have a value which represents the number of things in this array that are either even or odd. So let's say we call reduce on this array without giving it an initial value. If we call reduce, the accumulator will be assigned 1, and the current value will be assigned 5. Well, having 1 as an accumulator isn't really useful when you're trying to deal with multiple things at once. So let's see what we could actually do to make something like that work. So let's create something called even and odd and set that equal to the result of calling reduce, if I can spell, on numbers. And I'm going to pass in a reducer function, but I'm not going to write anything there yet. I'm just going to give it the parameters of counter and current. This time I'm not using the word accumulator because it's often more useful to give it a more descriptive name. In this case, I want to call it counter. So I'm not going to put anything in here yet. Right now, I want to focus on what our initial value is. So if we want to count multiple things, but keep it all wrapped up in a single value, we can just create an object that has multiple properties. So I can give it an even property, set that equal to 0 for now, and an odd property, and I'll assign that also 0 for now since we haven't seen anything yet. So this is what is going to be assigned to counter the first time our reducer function is called. So for now, the only thing I'm going to put in our reducer function is return counter. So if we show what's going on here with even and odd, we'll see that it's this object that has an even property and an odd property, both of which are for now 0. So we just return that over and over and over again until we reach our last element, and then just return that and assign this to even and odd. So what can we do to actually count even and odd numbers? Well, all you have to do is, well, first we check if the current is an even number. And we can do that by just checking if current mod 2 is equal to 0. And if it is, all we have to do is just say counter.even. We're accessing the even property on the counter object, and then just increment that by 1. And you can already see this is changing something in our even and odd object. And to get it to work for the odd, all I have to do is just add another conditional. And now I will just access the odd property and increment that as well. And we see that it's working. We have 30 numbers in our array. 17 plus 13 is 30. So it's capturing everything. So let's see exactly what's going on here. I'm going to add another strategic console log statement so we can see how our counter is growing. It's a little hard to see in the side here, so I'm just going to print this out in the terminal. So our object starts with an even and odd property that are both 0. So the first time we run through this, the first time we call our reducer function, the current value is 1. So that's an odd number. So we increment the odd property, and now the odd property on our object is 1. The next number here is 5. That's also odd. So now we increment it again, and our odd property has a value of 2. We come across 6. This is an even number. So now we increment our even property. So we see that it's keeping all the data from before because it's the same object. We're just passing around the same object, and every time we're just changing its value a little bit. So yeah, if you are just a little bit creative about how you're using your initial values, you can really use reduce to return whatever you want. You can return the most complex data types because fortunately in JavaScript, those all count as a single value. It's important to keep in mind that you do have to return something out of your reducer function. Otherwise, the next time reduce calls that function, your accumulator is not going to have any value. So let's see what happens when I comment out this return counter line. Okay, so there's suddenly all these errors. Even and odd doesn't have a value anymore. And we see twice, cannot read property odd of undefined. So that's because if I don't return anything, counter will become undefined here. And undefined has no properties on it. Undefined does not have a property called odd. So that causes an error. We see that it looks like it's working here. So we see that there is an object that says even 0, odd 1. And that makes sense because there is an odd number in the beginning. So the first time that this is called, this object still is our counter. But after we add this property onto it and fail to return it, counter just becomes undefined. And for the rest of the times this reduce function gets called, undefined is what we're assigning to the counter. And it won't go past single run because when we try to access a property that doesn't exist on this undefined value, it'll just crash. So it's really important to remember to return something out of your reducer function if you want it to actually accumulate anything.